Have you ever wondered how an analog speedometer works? Well, in this video, Auto Expose will explain in animation how an analog speedometer works. The first thing you should know is that speed is measured by how far a vehicle travels in a given amount of time. For example, if a motorcycle travels 10 meters in 1 second, that means its speed is 10 meters per second. Or in 1 hour, 36,000 meters per hour, or 36 kilometers per hour. To calculate speed, the speedometer uses wheel rotation. For example, if a wheel has a circumference of 1 meter, that means the wheel must rotate 10 times to cover a distance of 10 meters. If those 10 rotations take place in 1 second, that's equal to 10 meters per second. This wheel rotation is then transmitted to the speedometer input using gears and flexible wires. This causes the rotation of the speedometer input to match the rotation of the wheel. So, how does the speedometer convert this rotation into accurate needle movement? This is where electromagnetism comes into play. The end of this flexible wire is connected to a permanent magnet. In other words, this magnet will rotate as the wheel rotates. Then there's a cup-like component that covers this magnet. This is called a speed cup. This speed cup can rotate freely, meaning it's not attached to a magnet. Instead, it's attached to the speedometer needle. When the magnet rotates, it generates a magnetic field around it. But, as you can see, there's no coil here. This means the rotating magnet doesn't generate electricity, but rather creates a magnetic field around it. This magnetic field can affect conductors within its vicinity. The speed cup is also a conductor, and it's positioned around a magnet. Therefore, the magnetic field will influence the speed cup, causing it to rotate, but at a slower rate than the magnet. This concept is known as the eddy current principle. Then we have one more component. This is the spiral spring. This spring is a very important component because it is responsible for the speedometer's accuracy. This spring is attached between the casing and the speed cup shaft, so it keeps the speed cup from rotating, but the speed cup itself can still move. Why is this so important? As we discussed earlier, if the wheel rotates 10 times in 1 second, its speed is 10 meters per second or 36 kilometers per hour. The 10-meter needle should move and be held at this number, but if this spring is weak, the needle will point to a higher number. So this is what causes the speedometer needle to move back and forth according to the wheel's speed. The faster the wheel rotates, the stronger the magnetic field, thus increasing the rotating force on the speed cup. With a fixed spring elasticity, varying forces on the speed cup cause the needle to move in different directions depending on the input from the magnet. That is the working principle of an analog speedometer. Hopefully, it can increase our insight.